And I'm going to share my terminal window. And we'll walk through those commands together. Now, give me a thumbs up if you can see my terminal screen. You guys good? Okay, cool. Thanks, Kieran. So from the command line prompts, go ahead and type in PSQL. You can do this from any directory or whatever. It's kind of a global command, just like Mongo was. And that will dump us into our Postgres prompt. So I think you guys should have 9.6.2. I have 9.6.1, and that's fine. You guys are a little bit more advanced than I am. So is it just me, or his screen is just a white line? So can you guys not see my, are you guys having, go ahead.
It's a white line.
Just like
Okay. Yeah. Let me see. How about now?
Better.
Okay, cool. Sorry about that. Yeah, so go ahead and type in PSQL at the command line prompt. That's a global command. You can do it from anywhere. And then it'll dump you into our Postgres shell. And you'll know it because you have that equal sign and that hash right there. The other thing, again, just to remind you guys, if you want to play around in your Postgres shell, or even if you're trying to run an app, make sure that you start your Postgres engine by clicking on that elephant, and make sure that you have the little elephant icon up in the top of your dock. So we need, just like Mongo or MonGod, we need to make sure that our engine is running. So let's walk through that screenshot that I pasted in. So help is how to get general info on Postgres. Generally speaking, in Postgres, most of the commands start with that backslash or the forward slash. I always forget which one that is. Is that a backslash or a forward slash? What is that? Is that a backslash or a forward slash?
Backslash.
Backslash, okay, thank you. So in any event, most Postgres commands will start with that backslash. So backslash question mark will get you some help. And then backslash L, it's kind of like showing all of the databases in Mongo. So I have a lot of databases. I don't think you should have this many, but that will list all of your databases there. And if you notice, again, I don't think you guys will have that because you should only have like 3 databases at this point. But you see how there's like a little colon down here at the bottom of my screen. So that just represents that there's actually more to this list that actually continues. So if you get that colon, you can hit the space bar and that'll kind of scroll down the list. So anytime you see that colon and it's kind of in like a blinking state, it just means that there's more data down below the screen. So I have 19 rows. I have 19 Postgres databases right now. So backslash L will list all the databases. Now to connect to a database, which is what we're going to do, I'm going to connect to a demo DB database. And so it doesn't exist. So we're going to have to create that. So hold tight 1 second. I didn't put that in the lesson. Make sure I tell you guys the right command for that one. Okay, so let's do this. So we need to do create database, and let's call this demo DB for now. And then if we do we can hit the up arrow and do the does not exist. Was that the right one? Let's see. Give me 1 second here. Oh, I think I forgot a semicolon. syntax error. Try that one more time. So just as a general rule, whenever you type in a query or a SQL statement, you're going to need to put that semicolon. Otherwise, it's not going to like your statement. So that just signifies that you're finished with the command or what have you. There we go. Okay. So if you want to do create database, I'll pop this into Slack. But we need to make sure we put in that semicolon, or it's going to bark at us. So create database demo DB. And then to connect to it, we want to do \C and then demo DB. And we should get a message, you are now connected to database demo DB as user Mark Wright, or whatever the kind of the admin for your computer, whatever your username is. So remember that, well, if you want to put it into Slack. So as we're comparing and contrasting Postgres to the Mongo database, what would be the equivalent of a database table? So in Postgres, we're going to use tables. What would be the equivalent to that in Mongo? What did we call a table? So in Postgres, a table contains all of the instances of something. Close, yeah. So Alan says a document. Really close. Does anyone else want to take a stab? Just one level up. Yeah, collection. So Postgres, we have tables of rows of instances. And in Mongo, we had a collection that contained documents. And each document was a new instance of a user or a recipe or what have you. Cool. So let's go to this next one. To connect to a given table, it's going to be \D. And that'll list all the tables for this given database. Now, we don't have any tables created yet. And so you should get this message, no relations found. So let's create some relations. And I'm going to do this, I'm going to type this out longhand so we can talk about it. So we're going to, if you guys want to follow along, we're going to type in that create table Pokemon. We're going to play around with some Pokemon data. And this is what we need to do. So let's do a create table. And we'll call this table Pokemon. Now, as we go through this today and tomorrow, usually when you're using the specific SQL language syntax or queries and such, the keywords, if you will, the convention is to capitalize them. Now, all these queries and statements will work if you don't capitalize them, but it's kind of the convention to capitalize the actual keywords. It just makes it easier to read, particularly if you've got a really dense, several line SQL statement or query. So the convention is to capitalize the keywords for your given queries or statements. So create table, we're going to name this table Pokemon. And so we're going to pass in some arguments, some specific information for this table. So go ahead and open up opening parentheses. And then if you hit Shift and Enter, we'll go to a new line. And let's add the fields that we want this table to have. So the first field name, column or field name, we're going to have number. Number is going to be an int or an integer. And we want it to be unique. And we also want this to be the primary key. So this number, we want it to be unique because this is how we're going to identify each Pokemon. Generally you'd probably want to call this like the ID field or something, but for now we'll just call it the number field. But we want it to be unique, and we want it to be the primary key. So that tells Postgres underneath the hood, we don't want to have a Pokemon with the same number, because then we're not going to be able to look up the correct Pokemon in our database. So we want it to be unique and a primary key. And the primary key just means that Postgres is going to keep a really sharp eye on that field and make sure that it's unique, and it's also going to do some indexing under the hood And we'll see next week, or actually later today, when we seed our database and such. Remember in Mongo, we had that crazy object ID field, that crazy bson hash that was the identifier for each document. In Postgres, it's a little easier. So Postgres starts with the number 1, and it goes sequentially, 1, 2, 3, 4, 5. So it's going to make our lives a little easier. That being said, we still want Postgres to manage those IDs. We want it to make sure that we don't, accidentally assign the same ID to 2 different instances of a Pokemon or what have you. Cool. So that's the number field. Let's add the name field for our Pokemon. This is going to be a varchar, or variable character. So there's 2 types of character fields in Postgres. There's a varchar and there's a text field. I think varchar is anything less than like 255 characters, and then a text field would be larger than that. So you could use either one, but just to save space. I doubt we're going to have a name that's going to be more than 255 characters. And we're going to add a not null constraint to this. So that means that a name is required. So it's not going to save an instance of a Pokemon unless it has a name field. We'll add a type, and we'll do the same thing here. We'll do varchar data type and another not null constraint. And in description, we'll make this varchar, but we won't make this required. We won't add that not null. So description is going to be optional if we want or do not want to add a description field. And then let me hit enter, shift enter one more time, and we'll close out our parentheses. And then make sure you put that semicolon at the end. Otherwise, Postgres is going to bark at us again. So if we run that, you should get a create table response. And now if we go back and run that \d to see all of our tables, we now have one relation. And we can see that we have a Pokemon table. You can see the type. It's a table type. You can see the owner. And right now, we haven't created any Pokemons. We just have this one row in our table, kind of like the details of our table. And another command I put in here, if you want to see more details, there's not a lot going on right now, but you can also do a \d with the plus sign and then the table name. And this will just give you a little bit more information about your table. So here we can see the actual column names in our table. And my terminal's magnified, so this doesn't line up equally, but hopefully you see it a little bit cleaner on your screen. But you can see over here, I have number, name, type, description. You can see the type, the data type, integer, varying character, or the varchar. You can see the modifiers or constraints, such as not null, storage, stats, and such. So in this indexes, this Pokemon P key, the P key stands for primary key. And this B tree just means that Postgres is doing a special, B tree is a type of indexing algorithm. So it speeds up that database process. And so right now we want Postgres to index the number field, because the number field is going to be the unique identifier for each Pokemon. So again, we want Postgres to pay particular attention to that field because we don't want to create the same number for 2 Pokemon. That's going to mess up our data store. So yeah, \d+, and then the table name if you want to find a little bit more information. So how are we doing so far? Is everyone with me? Anyone getting anything barfing at them? So far, so good? Okay, cool. So let's walk through some CRUD actions, some basic CRUD. We're going to take, this afternoon when we come back from lunch, we're going to take a deeper dive into this. But let's take a look at kind of the basic CRUD actions here. So the basic read, or the index, if you will, if we want to get all of something, the way that we query that is going to be a select splat or star from, and then the name of the table. And then be sure to put your semicolon at the end of that. So select means we're getting some information from a table, and then the splat means we're getting all of something. So get me all of the instances from the Pokemon table. So if we run that, we shouldn't get anything returned because we haven't created any Pokemon yet. So the way that we can create a Pokemon is using the insert keyword. So insert into, and then the name of the table. So we're going to insert a record or a row into our Pokemon table. And then you want to pass in the arguments. So we're going to pass in a number and a name for this Pokemon. So you pass in the field names that you want to add some values to. And then you want to use the values keyword. So the first set of arguments is the actual fields. The second set of arguments is going to be the actual values that correspond with those fields. So and the order really matters here. So the first argument that we're going to declare is the number for this Pokemon. So let's make the value here. We'll just start with 001. Now eventually we're going to let Postgres create these for us. But for this walkthrough, we'll just go ahead and declare it manually. So let's just make a 001 for the number. And then for the name, let's name him, man, I do not know anything about Pokemons, I gotta be honest. Balasar? Are there any Pokemon fans in the house? I can only see like 4 people, so I should have done like good white characters or something. And then make sure you put that semicolon at the end of the statement because it's not going to like it otherwise. Oh, did I misspell it? I think I got it right. So let's hit enter, and you guys should be getting an error at this point. Null value in column type violates not null constraint. And then the detail for that error, failing row contains 1, Bulbasaur, null, and null. So why did we get this error? Why did Postgres barf at us? It has to do with that not null constraint. Nice, yeah, thanks, David. Yeah, so the type is missing. So remember up here, if we look, this is a little out of sorts for me, but remember that we put a not null constraint on type, meaning that we have to submit a value for type if we're going to create a new instance of something. So let's go ahead and add that now. So if you want to hit the up arrow for kind of the shortcut, and then let's skip over here, and in our kind of insert into Pokemon, so when we pass in the arguments for the field, let's go ahead and do a comma type. So we're going to add a value for type as well here. And then, so if you want to skip around, you guys are probably savvy at this. You can hold down Option, and then you can arrow left or right, and that'll just give you a quick and dirty skipping around on the command line there. And then for the type, I guess he's a grass type. And then if we hit enter, we get the Postgres response, insert 01. So we just inserted 1 row into our table. And if we want to confirm that, let's go ahead and do our select splat from. So that's kind of like, this is like the most general query there is. Select splat from Pokemon. And now we have 1 instance of a Pokemon in our database. And this is really nice. You know, it looks like a spreadsheet. I think this makes a little bit more sense. It's a little bit more structured if you're into that kind of thing. Cool. So give me a thumbs up in Slack if you have 1 Pokemon. So give me a thumbs up for that one, and we will move forward. And again, if you guys are interested, I'm not going to walk through it, but if you want to download one of those GUI interfaces, there's it was Postico, and then I forget the other one. That was at postgresapp.com. Oh, pgadmin. You know, if you want to download one of those as you're getting comfortable with relational databases, and those are a little bit more detailed, and you can actually click on those GUI interfaces and edit and create new instances of things. So if you guys are more comfortable with that, go for it. But we just want to encourage you guys to get practice doing this longhand and knowing how these things work. So 4 thumbs ups. We'll wait for 2 more and then we'll move forward. We have about 8 minutes. So we'll just finish up these CRUD commands and then we'll hop into our science fair.
Hey, Mark, I have a question.
Sure, go for it.
So I had a couple errors when I tried to create the table, but now I just can't create the table. And I feel like I'm missing something. I've gone through what you said a couple times. I'll just share my screen.
Okay, let me stop my share. Okay, go ahead. She blinded me with science. Maybe that can be the background music during the science fair. Okay, let's see here. Create table Pokemon. Number INT, unique primary key, bar card not null, bar card not null.
So this I just ended up literally copying and pasting because I was like, I keep having errors.
Yeah, so it may not like, if you copied and pasted, there may be some extra spaces in there or something.
Okay.
That may be the case because that looks okay to me. Yeah, see if that's helpful. Yeah, unique is misspelled there. Yeah, Postgres is really particular, again, with spacing, with the semicolon at the end of your statements. So make sure you get into that, be consistent about that. And after lunch, we're going to actually like create a schema in Atom and dump that into our database. So we won't be having to do all this, you know, with the shift enters. That can get a little tedious. So we'll be doing that after lunch. It looks like actually, so you should have can you scroll up a little bit, Sophia?
See, I did this a lot.
Yeah, keep scrolling up because, yeah, so I think it's still stuck because you see how your prompt is that open parentheses. We need to see an equal hash. So scroll down to the bottom and do a closing parentheses and a semicolon.
Okay.
And, okay, let's just do this. Do a \Q. So that's how we get out of Postgres is \Q. And just go back in and try it again. I think at some point, maybe you didn't close that off, and so it's kind of like stuck. So go ahead and do a PSQL to go back into the prompt. And actually, go ahead and copy and paste that one more time. So maybe it'll work now. I think you were just kind of stuck in limbo there.
All right. Oh, yes.
Okay. Yeah, I think you just got stuck there.
Thank you.
Cool. You're welcome. All right. So if you take a look in Slack, go ahead and copy. Let's create, I guess, like 8 or 9 Pokemons here. Let's go ahead and just dump these into Postgres so we'll have a little bit more data to play with. So if you want to copy that code, let me share my screen again and try to wrap this up in the next 4 minutes. Yeah, so grab all that garbage and you can literally just paste it into the prompt and we should be good to go. And note that after each one, we should see this insert 0 and 1. I think the 0, I need to check the documentation. I think the 0 is if we delete something. I forget what that 0 stands for. Maybe if we update it, it shows us like the version, how many times we've updated it. I need to look that up, but we should see all those 0s and 1s. And if we want to see all of that data, let's do another select splat from Pokemon with our semicolon. And there we go. So we should have 10 Pokemons. And notice, just for grins, we did 1, 2, 3, 4, 5, 6, 7, 8, 9. And then to be a little funky, we gave Pikachu the number of 2, 5. Now, if we were really doing this, we would want everything to be sequential. But just to kind of show that we can set that, so we should have 10 rows. Yeah, so Christine says the random O stands for the OID, the object ID of the row that was inserted. Yeah, so maybe that's some magic under the hood, how Postgres is indexing using that B tree algorithm, a binary tree, so that stands for. Cool, thanks for the assist, Christine. Great, so now that we have 10 folks, let's quickly, we'll cover this stuff again after lunch, but let's take a look at how we can update the Pokemon. Update and delete, and then we'll be good. So if you look at the screenshot I pasted in earlier, I'll paste this in again. So to update a Pokemon, we're going to use the update keyword. So let's update one of these bad boys. So update and then the name of the table. So we're going to update a row in our Pokemon table. And we're going to use set. So some of this should be familiar from Mongo. So if you guys remember, we use $set, which is a Mongo method. And so there's some similarity here. So update Pokemon set. So find any instance of a Pokemon with a type of fire. And it looks like we have 2 fires here, Charmander and Charizard. Oh my gosh. I'll let you guys worry about that one. So set the type of fire where the number equals 5. So actually, this is saying find the row where the number equals 5 and set that row's type to fire. So what we should see is Carmelian should go from type of ghost to type of fire. So that's the result that we want. So if we run that, and then if we hit the up arrow to go to select star or select splat from Pokemon, now we see that the number 5, Carmelian, now has a type of fire. So that's how we update a record. And you can probably figure this out, but you can set the filter. You can tell Postgres to sort how you want the results returned, but you can probably figure this out. So since Carmelian is the most recently updated record, you can probably guess that instead of putting this in sequential order, Postgres just puts the most recently updated on the bottom. So that's by default how Postgres will return these results. But you can certainly adjust that if you want. So that's how we update. And let's take a look at deleting Pokemon. Very similar, so we're going to use delete. So delete from the name of the table. So we're going to delete a row from our Pokemon table. Where, so we use where for both update and for delete. So where is how you can pass in specific fields if you want to get really specific about something. Probably like, I guess you could consider that like maybe find by, or what do we use? Yeah, in Mongoose we use .find, and then you could pass in the field and the value that you were looking for. So you can think of that as very similar using the where clause. Where name equals, and we'll delete Pikachu. And don't forget your semicolon there. And we get the response delete 1. And if we do that select splat from Pokemon, we can see that we have 9 rows now, and Pikachu has been deleted. And we are at time. So let's put a pin in it right there, and we'll just pick up after lunch. We've got a lot of cool stuff to get to after lunch. Let me stop my screen share, and I'll pass off to Christine. So Christine, how do we hop into the science fair and such?
Put the link in our channel.